There is one list that has quietly become the common language of AI security. Auditors use it. Regulators reference it. It turns up in security questionnaires, in procurement reviews, in board packs. It was updated this August, and it moved more than it has in any previous year. 6 of the 10 entries changed position. 1 changed its name. And, for the first time, the people who build it did something they had never done before. They checked their own list against the record of what has actually gone wrong. Give me the next few minutes and you will own this list. Not memorize it. Own it, with one sentence that holds all 10 in your head for good. 2 things before the list itself. First, the numbers are not severity scores. LLM 10 is not safer than LLM 01. This is a coverage list, a set of surfaces you need to have looked at, and the order tells you where the field thinks the pressure is, not what will hurt you most in your particular architecture. Second, and this is the part I would take to a board, the project leads open the document by telling you to stop trying to build a model that cannot be fooled. Build the system around it, so that when the model is fooled, and it will be, nothing important breaks. That single instruction runs through all 10 entries. Everything else is detail. Every earlier version of this list was built on judgment. Hundreds of practitioners voted on what mattered most. That vote is still the spine, and it belongs there. This year, they added something. They assembled a corpus of 7,714 real incidents from public vulnerability databases and an AI harm database, and built classifiers that sorted the 6,500 of those that carried enough detail. Then they asked one blunt question: does what practitioners fear match what the record shows? The answer was no, not always. And the disagreements are the most interesting thing in the document. Take prompt injection. Practitioners rank it number 1, rank the categories by raw incident count instead, and it falls out of the top 10 entirely. That gap is what they call a defense effect. Teams fight injection hard, so fewer clean exploits reach a public database. The low count is not evidence of low risk. It is evidence of money already being spent holding the risk off. Misinformation runs the opposite way. Voters put it near the bottom. The record put it near the top, the widest gap on the list in the direction that actually hurts. The vote won because the vote carries 3/4 of the weight, but the evidence pulled it up 2 places anyway. I want you to hold on to that asymmetry because it is a genuinely useful lesson about your own metrics. A quiet category can mean you are defending it well, or it can mean you are not looking. The count alone will not tell you which. Here is the sentence I promised. Something gets in. Something amplifies it. Something goes out. Every entry on this list sits in one of those 3 places, and once you see the grouping, you will not need to memorize the order. Group 1, what gets in? 4 entries. LLM 01, prompt injection still at number 1. This is any situation where input alters the model's behavior in ways the developer did not intend. The 2026 edition widens it explicitly to cross-modal attacks, instructions hidden inside an image or an audio track. The reason it cannot be fixed is stated plainly in the document. A model makes no architectural distinction between instructions and data, because both are tokens on the same stream. There is no equivalent of a parameterized query here. LLM 04, supply chain, down from 3rd. Training data, models, adapters, conversion pipelines, deployment platforms. New this year, the trust failure when a promoted model artifact turns out not to be what it claims to be. LLM 05, data and model poisoning, down from 4th. Note how far this has travelled from training data poisoning. Poisoning now counts anywhere data is ingested, transformed, retrieved, or reused, pre-training, fine-tuning, embedding, creation, retrieval augmentation, and distribution. Fine-tuning subversion was folded in this year. LLM 09, vector, and embedding weaknesses, down from 8th. Anywhere similarity search sits between a data source and the prompt, the embedding layer is part of your trust boundary. Retrieval augmented generation is the familiar case, but the same machinery sits under agent memory and semantic caches. Group 2. What amplifies it? 2 entries, and both moved up sharply. LLM 03, excessive agency, up from 6th to 3rd. The document calls this the most consequential move on the list, because the vote and the record agree that agentic deployments are where the damage is landing. Agency means the ability to call functions, invoke tools, act on the world. Excessive agency is having more of that than the task requires. LLM 06, unbounded consumption, up 4 places from 10th to 6th. Uncontrolled inference, denial of service, unsustainable cost, and model theft through cloning. In pay-per-token environments, this is a financial exposure wearing an availability costume. Your infrastructure will not crash, it will scale, and it will bill you. Group 3. What goes out? 4 entries. LLM 02, sensitive information disclosure, holding at number 2, the one place near the top where belief and evidence simply agree, and where the project's confidence is highest. Note how wide the channel is, not just the final answer, but tool call arguments, reasoning traces, retrieved chunks, logs, telemetry, embeddings, and even observable timing behavior. LLM 07, misinformation, up from 9th to 7th, the entry the leads specifically asked readers to slow down on. The risk is not that the model is wrong, it is that the wrong output is trusted and acted upon, and in modern systems, output drives tool calls, generates code, and authorizes actions. A wrong answer becomes a wrong action. LLM 08, hidden context exposure. This is the renamed entry. It used to be system prompt leakage at number 7. The rename is not cosmetic. The old name implied one artifact. The new one covers the unauthorized extraction, inference, or reconstruction of any hidden operational context, system instructions, policy logic, tool definitions, trust boundaries, workflow criteria. LLM 10, improper output handling, which fell the furthest, 5th to 10th. And here is the trap. It fell because everything above it became more urgent, not because it got safer. Its scope actually grew this year to cover the insecure code that assistants now generate at scale. Do not read a drop in rank as a drop in risk. One more thing, and it matters more every year. This list owns the risk when the model is a component inside your application, taking input, producing output. The moment that model becomes an actor with tools it can call, memory it carries between sessions, and consequences it sets in motion downstream, the risk moves to a different framework, the OWASP Top 10 for agentic applications. The document is direct about this. Many of the incidents they read sit right on that boundary. Read an entry here for the model as component failure, and when your model starts acting on its own, pair it with the Agentic list, because neither one covers that ground alone. I will take the Agentic list properly in a later episode. For now, the useful question is simply, which side of that line is the thing you are about to deploy? So, what do I actually do with this list? Having now read it 3 times, I do not use it as a checklist. A checklist invites you to confirm that each category has been considered, and considered is not the same as tested. I use it as a coverage map, 10 surfaces, and for each one, a single question. In my architecture, is this reachable? And if it is, what happens on the day it is used? I pay attention to the seams rather than the categories. Injection is the trigger for excessive agency. Hidden context exposure becomes sensitive information disclosure. Improper output handling is what turns a text problem into a system compromise. The incidents that actually happen run across 2 or 3 entries. Single category testing will not find them. And I treat rank movement as information about the field, not about me. Excessive agency climbing to 3rd tells me where the industry is getting hurt this year. It tells me nothing about whether my own deployment has an agency problem. Only my architecture can tell me that. The line I keep coming back to is the one the leads open with. Build each of these for the day the model is turned against you, not for the day it behaves. That posture is worth more than the list itself. One sentence to keep. Something gets in. Injection, supply chain, poisoning, embeddings. Something amplifies it. Agency, consumption. Something goes out. Disclosure, misinformation, hidden context, output handling. 10 entries, 3 groups, 1 posture. Assume the model can be fooled, and make sure that when it is, nothing important breaks. The written version of this, with the full rank movement table, is on the site, CompoundTrust.in, under Field Notes. I am CompoundTrust, a security veteran's field notes for the AI era. Trust compounds. We set the rate.